Myself, S. Omkar Raju. I am pursuing BTech in VVITU College from ECE department. I am telling about the topic total probability. In total probability, there are some contents I choose. Introduction, definition, explanation, example, and its applications. Suppose we discuss about introduction. In introduction, we will discuss about the some 3 points. The theorem of total probability helps in finding the probability of an event by considering different cases or partitions of the sample space. The law of total probability is a fundamental concept in probability theory. It provides a way to calculate the probability of an event by considering all possible ways in which the event can occur. When a sample space is divided into several mutually exclusive and exhaustive events, the probability of any event can be obtained as the weighted sum of its conditional probability with respect to this event. Suppose if I am telling about total probability definition, let me discuss about total probability definition by exhausting the formula. If in set of B1, comma, B2, comma, and so on, Bn is a partition of the sample space S and A is any event, then P of A equals to P of B1 into P of A by B1 plus P of B2 into P of A by B2 plus and so on plus P of Bn into P of A by Bn. I am telling about the explanation. Suppose if we discuss about the explanation, we can tell about some points. I am telling about 3 points. Divide the sample space into mutually exclusive events. Use conditional probability for each participation. Add them to get the total probability of an event. I am telling about the explanation. I am telling about the example. Suppose a factory has three machines, A, B, and C, producing bulbs. A produces 30% of bulbs, B produces 50% of bulbs, C produces 20% of bulbs. Probability of a defective bulb. A equals to 0.01, let comma B equals to 0.03, C equals to 0.02. Find the probability that randomly chosen bulb is defective. Then we have a formula that another we discussed about in the last slide, that V of B equals to 0.3 into 0.01 plus 0.5 into 0.03 plus 0.2 into 0.02 equals to 0.023. Some of the explanation about total probabilities. Suppose we discuss the mutually exclusive events. There are means or no two events can happen at the same time. P intersection P equals to 5 for I is not equal to 0. For exhaustive events, the events together cover the entire sample space. Suppose B1 union B2 union so on union Bn equals to S. Suppose we discuss about conditional probability, then the law uses conditional probability P of A by B, which tells the chance of event A given that B has happened formless. Suppose P of A equals to sigma I equals to 1 to n P of B1 into P of A by B1. Suppose its meaning is, it means to find the probability of A, add up the probabilities of A happening through possible case B1. Suppose we discuss about some example applications in total probability. There are some risk analysis. In risk analysis, we can discuss about the total probability. The total probability is usually discussed in risk analysis, and there is a reliability engineering. In reliability engineering, the total probability is usually used in many things. In reliability engineering, suppose examples, in engineering, the total probability was estimated to find the costs and the efficiency of the material. Machine learning. The total probability is very usually used in machine learning. Machine learning today's in nowadays the machine learning is thing is going exhaust and elaborating. In machine learning, we are using many formulas about total probability and many things. And suppose decision making under uncertainty. Decision making under uncertainty reveals many things. Suppose medical computing marginal probabilities. Used when an event depends on partition of the sample space. Medical diagnosis screening combine degrees, prevalence, and the test sensitivity. Suppose reliability. When we use reliability compute system failure probability by conditions on which components fails or operating conditions. Example, Bayes theorem professor evidence them. The documentator of Bayes rule is computed by total probability. Risk assessment under seniors aggregate risk across mutually exclusive sensors, weather states, market regime, user behavior. Mixture model with hiding classes. When data arise from several sublations, marginal likelihood is a mixture of conditional likelihoods. Example, mixture density. Suppose a computer expected utility by summing utilities conditions on outcomes weighted by outcome probabilities. Example, choose action maximizing. Sequential Markov process. Hidden Markov models. Speech recognition. Marginal probability of absorption sequences is computed by summing, integrating, or hidden state sequences principle uses total probability with a dynamic program. Law of total expectation or variance. Variance of x equals to E of variance of x by y plus variance of E of x plus y. Suppose in decision making under uncertainty, we are using law of probability many sense. Suppose if we are going to choose in making any climatic changes, the total probability is used many widely. In climate changes, we use very frequently and suppose if we are using many things in so if we taking in climate changes, we are using the formula by variance or something decision analysis. In decision analysis in computers, we are using many risks, risk analysis and reliability in machine learning, we use this widely. Decision analysis. Compute expected utility by summing utilities condition on outcome well. Outcome probabilities. Example, choose a maximum sigma u of a plus b. Something we have discussed about in the last set. There is a formula. By using this formula, we can easily find out the total probability. In total probability, there is a we majorly uses risk analysis. And suppose we discuss about the Bayes theorem. Bayes theorem, the denomination in Bayes rule is computed by the total probability is very widely used. It will use in sigma I P of E by Hi into P of Hi. Uses converting likelihoods into posterior probabilities, risk assignment under seniors, aggregate risk across mutually exclusive scenarios, users behavior, mixture models and hiding classes. When data arises from several substations, marginal likelihood is a mixture of conditional likelihoods. Example, mixture density, decision analysis, expected utility, outcome probabilities. Example, choose action maximizing. Sigma u of a comma 0 is equals to p of oj. Sequential Markov process. Stepwise conditioning. Compute probabilities at a time by conditioning on previous state that from a partition. P of x base n plus 1 equals to x equals to sigma y a of x n plus 1 equals to x divided by capital X power n equals to y. Suppose we discuss about the speech recognition. In speech recognition, marginal probability of an absorption sequence is computed by summing or integration over hidden state sequences. Principal uses total probability with dynamic programming. Forward and algorithm. We discuss about some topics about total probability. Now we are skipping conclusion. So for example, if we are going to the total probability conclusion, the theorem of total probability is a fundamental tool in probability theory. It allows us to compute probabilities by considering all possible cases. For example, when we came to the conclusion, in conclusion, we are discussing about many things. So the overall total probability is vastly and widely used in many situations and many examples. So now we are ending. Thank you.